Today we are going to start prompts, prompt templates and chains. And we're going to start our journey into LangChain. We did a little bit of LangChain last week or 2 weeks ago when we looked at model routing, basically how you can use LangChain to abstract all of the different API calls that you would normally have had to do on your own in order to be able to interact with these AI uh, large language models. So we also talked a little bit about prompts and prompt chains. We've looked at it before. We're going to do a bit of a recap, but this time around, we're going to delve deeper into what prompts are, what prompt templates are, and then prompt chains. So we are going to do a review and a recap of prompt prompt engineering basics and chaining techniques. We've already done a little bit about chaining. In fact, I think the last task was prompt chaining, right? But this time around, you were not asked or you asked not to use LangChain, but normal API or SDK. And the reason for that is to be able to understand the inner workings of how a chain, works. So then we'll look at some of the approaches. These are more or less recap of what we've done already. Then we will talk about prompt chains and optimization. And we'll do an introduction to LangChain LCell, which is um, LangChain language for basically chaining language. And then we're going to look at prompt templates. The way prompt template, a prompt template is basically you know, a reusable uh, prompts that you can inject, um, dynamic variables into it. But we'll look more at what that means and what that does. Then we'll now look at how we can have improved prompt management using LangChain prompt templates, or even just a concept of, um, you know, the prompt template. Then we'll delve a lot more into LangChain, the LangChain language for chaining and the concepts of runnables, which is what is really built around. Even though these days it's not a very big deal anymore these days, right? But um, it's still something we'll look at. The world has moved on, but it's still good to understand, to look at it and to understand. So that is our plan for today. So as a recap, I want us to look at the um, we talked about large language models, and we talked about the fact that with large language models, you should have an understanding of what is going on behind the scenes with large language models. Because when you understand what is going on behind the scenes, then you'll be able to understand some of the reasoning behind why we prompt, why we even write prompts or how we should write prompts, right? It's very important to understand that dynamic or that background. So let me recap that. The first insight from having a bit of understanding of large language models is that a large language model is a next token predictor. It just predicts what is the most likely next token, given a whole sequence of tokens. Of course, tokens in this case essentially translate to the words that you type and give to it, which we call the prompt, right? So having an understanding of that means that you get a better output if you give a clear input, a clear structure with examples. The more clear and structured and specific your prompt is, the better the output you will get from large language model. If you want to try that principle, go and ask a large language model to give you anything. Even today, with all of the scaffolding that's built around large language models to make them much smarter, much more intelligent, to have them do really incredible things. You still have situations where if you are not very specific or expressive in what you're asking it to do, it tends to go off. So always remember that. Then the second thing is that they have a limited context window. They are limited in the amount of inputs that you can give to them. So that means that the inputs you give has to be focused, and sometimes you have to chunk it. In other words, if the inputs get too too much, which is what will happen, for example, if you're having a long conversation, you have to figure out how to compress or summarize things. So you always have a limited context window, and that will affect a lot of other decisions that you make as you design your system or as you build your system. Then the third thing is LLMs have probabilistic outputs. Yeah. So because they're probabilistic, sometimes if you ask the same question multiple times, you will not get the same answer. That's what that means. But it also means that it is statistical. So it actually has its response is based on distribution of knowledge that it has. What do I mean by that? It's trying to predict, essentially. So it's always better for you to ask for grounded knowledge, ask for reasoning, right? Ask for comparisons, ask for citations. Don't ask for its opinion. I find myself doing that also, and sometimes I fall into that trap. What do you think? Which is the best approach? If you say which is the best approach, it's even a better prompt because in a way it would interpret it to me that you wanted to compare different approaches, right? But if you go right off with nothing and ask a large language model, okay, what do you think about this? Or, or give me ideas on this. It can just give you anything. So it's always very good to be very aware of that. It's also sensitive to role and the task framing. Even though these days there's a whole lot of system prompts and things, and some of these models have been so well trained anyways, that you don't always need to tell it you are a senior engineer or you're a junior engineer. But even with that, it is still a good idea to frame the scenario, the context. The context matters so that it is able to generate what fits into that context. So always include the role, the objective, and format in your prompt. Then it imitates patterns. So that one is always provide a sample format. We'll talk about that when we're talking about structured output. Okay. Then it it doesn't plan steps, right? The large language model cannot really plan, but you can encourage it to plan. Um, so the best approach would be ask it for a plan. When it gives you a plan, then you ask it to follow the steps in that plan. If you do not explicitly do that, right, it will not do it. If you give it a complex task, it will try to solve that complex task in a single go, right? What we call one shot, which is not a good idea because it will hallucinate a lot of things in between, right? But if you, just like a human being, if you ask a human being to come up with a solution for a mathematical equation, for example, it cannot come up with it. But if you ask it for the steps to follow, it will, a human being can come up with the steps and then follow the steps, right? That's kind of the same thing. So always, and that's where the whole idea of prompt chaining comes in, where break every task into steps and then follow the steps, right? Even agentic processes, the new agentic type of AI that we have they follow that same thing. The only thing is that the process of breaking it into steps and following is now automated. They are able to reason that on their own rather than being told what steps to follow. And we're going to look at that. So what is prompt engineering or prompting? I prefer to call it prompting. Is a practice of designing and refining inputs that guide AI models to produce accurate, relevant, and high quality outputs. So it's not even a one stop or one step thing. You could write a prompt and you pass it to the large language model. It doesn't give you what you want. Then you can refine it and you continue to refine it. So the question is, after you have finished refining a prompt, what do you do with it? Do you throw it away? Do you lose it? No. A prompt becomes another piece of your software, of your source code. This is the fact, right? Think of a prompt as a specification document. The clearer and more structured it is, the better the AI understands what to produce. A prompt is just for me, it's a program that you have written. The only difference is that instead of writing it with some high-level language like JavaScript or Python or C++ or um, Java or Kotlin or whatever other high-level language you can think of, it is written with natural language, the natural language that a human being understands, because the AI, a large language model, has been trained to understand natural language. So you write it. So the rules still remain. It has to be clear, it has to be structured, it has to be specific, it has to be as all the contexts have to be captured in it, right? The only difference is that you're no more using symbols and keywords, right? You are just using free-flowing language, but it still has to be specific. And when you have put in a lot of effort to fine-tune your prompts and get it to a point, do you want to keep doing that each time? No. You want to keep it, you want to save it. It's a specification document. It has to be stored somewhere. So these days you even have in code bases, there are specific areas now that a lot of different providers have designated for storage of prompts. So you can have like a dot prompt folder or a dot Claude folder or a dot GitHub, or different, or some of them have .md file, that is the markdown files that are given special names, right? To basically say, okay, this is where we are storing. And these days, prompts are used with the markdown language because it um, allows you to differentiate different, aspects of the prompt while making it still human readable. Okay. So prompts, you can highlight the ones that you want to serve as major headers and so on. So the markdown language is markup language, but it's called markdown, which is interesting. But the markdown language has become like the de facto means of writing prompts. You can still write them as plain text, but you cannot separate things in the way or annotate things in a way that is visually pleasing. That's why Markdown is very good. And you find that most of these large language models have been trained to generate their output in Markdown by default if you don't specify a particular language. So that's what a prompt is, right? And like I said, the structure of an effective prompt, first of all, always specify a role context, persona, right? You're a senior Python developer, a senior, engineer or something. Always specify the task you want it to do. It needs to be as precise as possible, as specific as possible. Any aspects that you do not specify, obviously the large language will be free to choose, right? While that is okay because you're not supposed to specify every single detail, but what you need to realize that any aspect that you do not specify, the language model will choose whatever it chooses, right? So that's why you have to apply constraints. You need to remember to apply constraints. You need to specify limits. You need to specify requirements. And there are two ways you can do this. You can apply constraints, positive or negative, right? Positive is specifying what it should do, and the negative is specifying what it should not do. By the time you combine those two together, right, you will be able to cover most of the areas that matter to you, right? Then, of course, like we said, you specify the output style or format. This is very important in the situation where you want your large language model, the output from it, to be plugged into a traditional software program that you already have, like a tool or some other program that you have or you are building, where you have designed and built it for structured input. So the LLM needs to give you an output that fits that format. And in fact, you would need to do validation. That's part of what we're going to talk about when we talk about the consuming what these large language models are providing. So these are some of the examples that you can use. So for developers, this is kind of more or less a repetition of the same thing. Be specific, avoid vague requests, right? Especially if you want to use generate code, set the rule. We've said that already. Iterate. So iterate is what I said. It's not the first prompt you write that you will use. Just like a your code that you write, when you write it, you test it and you see if you get the output that you need. If you don't, then you can go and fine tune the code. You can go and improve on it. You can find where the bug is or where the error is, and you can adjust it. The same thing with prompts. When you have written a prompt, you run it on the large language model. If it gives you what you want, good. If that if it's not exactly how it should be, you can come back and tweak the wording. You can add more constraints. You can be more specific in some areas. Like I said, any area you are not specific in, the language model will choose. So always be specific in the areas that matter most, the areas that you are not too worried about, that it can decide whatever it wants to do. You can leave those because you also want the language model to be flexible. You want the LLM to be able to come up with, to be able to handle multiple situations. So if you are too precise in everything, you are also constraining it. Then, like we said, decompose your task into smaller steps. Use delimiters. Delimiters are very important to separate the different parts of what you are giving to it. And we're going to see examples of that. Um, so some of the constraints that you can define would be what programming language, if you wanted to generate code, what framework, to use, coding standards, output formats. When you are requesting structured output, always specify. And it's always a good idea to give an example of that structure. We're going to look at that. So an example of that structure, this is a good example of saying, okay, I want the output in JSON format following this schema. Another way is, well, eventually when we start talking about schemas, for some of these frameworks that use schemas like Zod, like Pydantic and so on, what's actually happening is that eventually it still goes back as a prompt and as an example. Everything that an LLM consumes is natural language, prompt. This is one thing that we need to understand. You cannot send it binary, right? Well, maybe it can read binary, the ones that are trained to do it. So always request for structured output when you are using the LLM for as a support to your software products that you are building. Otherwise, you have problems. If it is just for chat output to human consumers, you could let it generate as it wants. But then again, you also want to be able to um you want to be able to format the output in a way that is meaningful to people. So sometimes at the end of the day, you still have to ask for specific structured output. So these are some of the common patterns if you're using it as a programmer. Uh, Code generation, generate an endpoint for this. Code review. In fact, I have a prompt that I have used for code review, which I'll share with my um, team. You can see it's very extensive. We are going to see some of these examples. So review this code and identify. These examples are actually quite short. In real life, you are going to end up writing very long prompts because you want to put in as many things as possible. And we're going to try a few of them. Refactoring test generation. So the core components of a prompt, you have the system instruction. So like I said, the system instruction is a prompt that always gets sent to the LLM along with any user prompts that you send. So anytime you send the user prompt, the system prompt is constant. And the system prompt kind of gives it a framing of how it should behave or what it should do. So think of it like, you know, you don't want to always repeat some particular instructions, but those instructions are always there. So you put that in the system prompt, and then the user prompt goes in. So the user prompt, of course, is the one that you type that keeps changing. The context is additional information, right? Context can be, and these days, context becomes the most important thing because without context, the LLM doesn't know how to respond. Yeah, the system instruction is there, prompt is there, but if you do not have context, it does not know how to narrow its response in a way that is helpful to you. So, for example, good example of context is the conversational history, the previous conversation you have had with it. If you didn't give it that previous conversation and then you ask, what did we just discuss last time? It will not know because the LLMs are stateless. The information or the input you give to them, that's what they deal with. They do not normally keep any history. So all history has to be sent along with the current prompt and the system prompt. Okay. So, and then you have examples. So examples is where is well few short in the sense that you can give the examples of how to do stuff, right? So it helps. Then the output format, like we said, and the constraints. So what are the type of prompts that we have? Um, for reasoning, we have what we call advanced reasoning prompts. Advanced reasoning prompts are prompts that help the this is in agentic context. It helps the large language model, the agent, to figure out how to reason about the uh, request or prompt that you have made to it. So we have a chain of thought, which is structural instructions forcing the model to generate a linear sequence of intermediate steps before producing a final answer. So in this case, that prompt, you are asking it to think about the problem, to list out a sequence of steps to take, and then to follow those steps before giving you an answer. That's what a chain of thought prompt is. A tree of thought prompt is a prompt like a chain of thought, but there can be multiple branches back and forth, which allows the model to do some evaluation as well. So it can actually go through multiple reasoning paths and then backtrack when a branch fails. So the interesting thing is this is still a prompt that you will give to it. So unlike a chain of thought that is just a single linear sequence of steps, this one is branching at different points. And when it gets to a certain point, if there's a failure, it comes back. Then you have step back prompting. So this is kind of a prompting approach where you are asking the AI to extract high level concepts first before trying to delve into more specific stuff, right? So again, each of this is just an approach that helps the AI or the LLM to break down the task instead of trying to deal with a big task. In other words, the prompt is teaching the LLM how to think or how to approach the problem. The prompt is telling the LLM how to approach the problem. Okay. Then the least to most prompting is a breakdown methodology that prompts the large language model to first of all list all the sub problems and then systematically solve them in order. So this is kind of more it's same thing as okay, break it down into sequence of tasks, right? The only thing is that if it's a problem, it is sub-problems and it starts with the least and then goes to the most. Then we have other kinds of prompts. So structural data prompts are prompts that basically you want to you want the model to be able to respond without giving it any additional data. So a zero-shot prompt means you give it a prompt without any example, and the model will give you a response based on training data that it had before, based on training data that it had before. Um, so that's typically like you didn't give it any additional data. That's zero shot. A one shot or few shot prompt is where you include one or more examples, right? Based on that example, it should be able to give you an output. So even though it says to train the in-context behavior of the model, that's you are essentially training it in a way, not training it as in altering the parameters of the model, but giving it rules and bases in of how to arrive at different have the system or rule prompts, which are the ones that we kind of have talked about, high level persistent instructions that enforce personas. So where that's system prompt basically. The system prompt is the one that you say that is always persistent, while the rule prompt is the one that comes at each point. And you can specify you are this or you are that. It gives it the personas, it gives it the behavioral boundaries and safety guardrails. So interestingly, safety guardrails are also brought in as prompts for large language models. For example, you give it a guardrail that says, do not allow um, vulgar words in your response. You can put that as a part of system prompt. Do not allow vulgar, or if there are any vulgar words, then redact them. It is still the large language model that you are using to give that prompt. Okay. Then the last set or last category of prompts are framework and dynamic prompts. The framework and dynamic prompts are prompts that are designed for agents, right? Basically, to give them additional capabilities. So the first one is the react. The react means reason and act. And we'll talk a bit more about that when we get to the agentic part of this course, where we are going to talk about agentic reasoning. So, but the react is a prompt that is designed for agents to switch between generating reasoning, right? And then executing. That's why it's called reason and act. So during the reasoning phase, it will reason about the input you have given to it. It will generate what we call tool calls. And those tool calls are based on tools that you provide to it. And we're going to talk about tools later. And then that will be the reasoning phase. Then in the acting phase, it will execute those tool calls. The tool calls are not really executed by the LLM, but by your code, your own code. Tool calls are essentially code written by you that get executed. So the LLM will call those and they'll be executed. And then the results from the tool calls will be used for another round of reasoning. And if the next round of reasoning also requires additional action, right? Another round of action takes place. That's why it's called a react loop. It is a loop that continues until it gets to a point when after the final round of reasoning, there is no more need for action, but the response is now ready and the LLM sends that response to back to the user. So that is a reason and act loop. And there are other different ways too. There's also, like we talked about earlier, there's also the chain of thought and tree of thought and all of that. Then meta prompting is prompt that you use to instruct an LLM to generate, evaluate, or optimize other prompts automatically. So you could actually write a prompt for an LLM to generate other prompts, and then it will follow those prompts. In a way, React is kind of something like that in a way. At the end of the day, it's all about prompts. And that's why when we talk about large language models, AI of today, and we talk about prompting and prompt engineering, it was a really big deal because people figured out that it's really all about prompts. But these days, it's not just all about prompts. There's a bunch of other things as well. Then, of course, we have the retrieval augmented generation RAG prompt. So a RAG prompt is a prompt where you pull external data and inject them into the context window, or basically inject them into the prompt, right? Because when we say context window, we are still just talking about the entirety of the prompts that you send to the large language model. So they're injected into the context window, right? So that additional data helps the large language model to reason about that data. So instead of hallucinating or coming up with things that don't exist, it will look at what you have given to it and use that to generate its responses. So typically, in a RAG context, you don't just pull any data. The data has to kind of match the original prompt or question that was asked, right? And that is where we talk about semantic search and embeddings. We are going to look at those next week. So that is kind of all there is about prompts. Now, let's talk about prompt chains. So we've already said that a single prompt is not enough in most situations. A single prompt is not enough in most situations. So if you have really complex tasks, you will need to split into multiple steps, okay? Because if you do that, the quality of the output, if you don't do that, rather, if you try to squeeze everything into one prompt, the quality of your output is going to be very low. Because first of all, you have a context window limitation. The context window limitation is going to prevent you from writing the full length of prompt that is needed. Secondly, even if you could, if the amount of information is so much, the LLM actually degrades, the output degrades. So you would typically want to be able to split the task into different smaller chunks, like we have said. And then you can do those in sequence. So you have each task with its own corresponding prompt, right? And you do that in sequence. So most complex tasks will require analysis, planning, generation, then validation, right? So a good example is, we'll talk up more about this example where you have to generate requirements, architecture, code, test, and documentation, right? So it's not a good idea to try to squeeze this into a single prompt. That's where the idea of prompt chaining comes from. But prompt chaining, right, is not the same thing as just I have five different prompts and I'm running them one at a time. That's not really prompt chaining. Because if I took one large prompt and I split it into five smaller chunks and then I run those one at a time, that's not really what makes it a chain. Because what makes it a chain is that you are linking the prompts together. In other words, the link there is that the output from the LLM executing um, one prompt is used as the input into the next prompt. It is injected as a dynamic variable into the input of the next prompt, right? And so on and so on. I continue that way, and that is what forms the chain, right? So this is always very useful for most multi-step reasoning. The other interesting thing with prompt training is that it is not the entire output that you get from the previous step in the chain that you push into the next step. Sometimes you may summarize. Sometimes you may remove some of them. Sometimes some of the outputs may not be used, right? Sometimes you even use an LLM to determine what should be used into the next step. Okay. So in prompt training, output one prompt becomes the input of another. That's a simple thing. And the benefits of it is you have better reasoning because you have simplified each an entire complex task into smaller units, and each step or unit is easier for the language model to reason about. So it will come up with better reasoning. Maintainability is improved because you now have five prompts. You can decide to tweak only one of those prompts until it gives you what you want. And if you need in future to make changes, you don't need to go fix the entirety of one large prompt, but you just pick the ones that you need to fix. It's also reusable workflow because it means that if you build it, you can reuse that workflow for a different kind of problem just by changing one or two prompts in that chain, right? Or you can even build an entire workflow and then you change all the prompts. And a single workflow can serve multiple purposes by simply changing some of the prompts or all of the prompts. It's easier to debug as well. So again, this is an example, right, of how you would use that. So you can see building a REST API, the first step in the chain will be to generate the requirements. Then the next one will be generate architecture. And then the next one will be generate database schema. And then generate source code. And then generate tests. And then generate documentation. So all of this is indicated by this simple flow chart here. So, and that's it, right? And like we said, the output from each one becomes input into the next one. So while you are doing prompt training, there's optimizations that you can carry out, right? The first one, like we talked about, is context compression. I've already mentioned this. You don't need to pass in everything that came from the previous prompt or the entire output. You can compress, pass only the relevant information forward. That's what makes it easy because if you did not split into smaller steps, what would have happened is that the large language model will have to deal with a lot of information, a lot of context, right? But when you split it, you're essentially splitting context into smaller chunks. And then when the model reasons about it, it doesn't need as much context to reason about a smaller subset of that task. And then the output comes, you now have a kind of, you know, processed thing, and you only pass what is relevant into the next one. And you could even go to a point where you ask the language model to give you the output in a structured format. So you can write your own customized code to filter out what is needed and what is not needed. Of course, example is what we did in the task, which we will use as an example here. Then, and that's where structured outputs comes in. Like I said, with structured outputs, you can then it's easier to separate. You can hard code that. You can use a rule-based system to hard code that. You don't need even a language model to trim down. You only take what matters. So if it's only the requirements, for example, that you need for the next step, then the next um, prompt in that chain, you only pass this in because you have asked the previous chain, the output, to give you a structured data, right? And so on and so forth. Then the other interesting thing and the value of having a, a chain is that you can add additional prompts to verify. One of the things that you will learn in the course of this thing is that large language models are really good at validating themselves. In fact, generation is much more difficult to do than discrimination or validation. For those of us, you see that if you take a copilot, for example, and generate some code, give it a prompt, say generate code to do this, it will generate the code. Then take the same copilot, the same language model, and ask it to review that code and find errors. It will find a million errors. The same code it generated, it is now finding a million. So generation is much more difficult than discrimination or validation. And it's the same thing even for human beings. If you ask a human being, go and write something, right? And then you ask another human being or the same human being, it's easier for you to find mistakes in what you did than generating it. Think about it. If you are playing a game of chess or draft or whatever game, right? It's easier for you to see that you made a mistake after you have played it. Why? Why didn't you see the mistake before you played the move? It's after you play the move, then you go back and do validation. And you say, wow, I just blundered. And then you hope that the other person didn't see the blunder. It's the same thing. Generation requires more cognitive load than validation. So adding verification prompts to check what was done is a best practice, right? We'll also look at that. Then self-critique, which is kind of what I just said. Review the previous output, identify weaknesses. So these are ways to optimize. So that is that. Now, before we jump into um, you know, LangChain and LangChain LC, LangChain expression language, I would like us to just try some of these principles. So of course, we already had a task. Now let me see if I can bring that up. Of course, you can do this with any language, right? But I will use an SDK for this. So of course, again, the same thing can be applied to both JavaScript and Python. So now here I want to do something. I want to do a simple problem that requires um, chaining. So we'll start with let's use OpenAI. Okay, so I'll need to create my environment variables. Of course, as usual, we have to create .env. So I'll wait for this to get set up. And we also look at prompt templates as well, because I've not talked a lot about prompt templates. But a prompt template is basically just, you know, we'll come back to it, but we'll do a bit of it. A prompt template is just a saved prompt, right? Where you can inject some dynamic, you know, information. So you create placeholders for the dynamic information. And then at the point of generating the prompt, or the point of using the prompt rather, you you will then inject the dynamic components of the prompt into the template. Okay. So maybe I should just put this in here, or maybe we use this as the default. Okay. All right. Let me go get an API key. Okay, well, I'll just keep I'll keep coding while waiting for the API key to show up. Okay, so we have a client. Now we can make the first thing is let's have a system prompt. Okay, first of all, let's have a problem that we want to solve. So let's assume that we are writing banking software. So the problem is this. Let me put this in um, yeah, let me put this as this. So the problem is we are writing banking software. It, okay, well, let me not make it exactly what we have as a task. Okay, we are writing a customer um care or a customer support AI for um for an e-commerce site. Yeah, so this it's expected to tell customers about products in the site and answer questions and direct them on what to do. Now, what makes this particular kind of problem more difficult is that the AI needs to know what products that you have. Okay. So where would that information come from? But let's say you provide that. So maybe let's assume that you have just four different products. So the first thing is um, you could you could decide that you want to um, split this into a prompt chain, right? Um, so you first of all have a system prompts, the prompts that you have. You first of all want to have a system prompt. So this gives an overall idea to the AI of what it's supposed to do. The second one is then the prompt chain itself. Okay, so the prompt chain is for every inquiry. Number one, identify customer intent. Number two, classify the request based on pre-existing categories. Number three, after you have classified based on pre-existing categories, you could also say, well, let's just classify instead of saying, oh, give me the best fit, right? Um, After classifying, determine whether the request requires an immediate response, okay, or not. And then you could say something like, if it is, if it is, if it is a product inquiry, right? Let's do a little bit of RAG here, a little of manual RAG. We're not going to go too far. In fact, this involves all of the things that we're talking about, RAGs and tool calls and all of that. But we'll do it at a very low key. So if it is a product inquiry, you can say check, um, get the information from a database. Um, so these are some of the things that you are now kind of um, determining, because all of this would not come out immediately if you put all of this in a prompt. So if it's a product inquiry, get the information from a database. If it is a user complaint, then handle it and handle the issue, right? Handle the issue. Um, well, okay, let's say collect more data on the issue, and then respond to the user in a polite, friendly manner. So now we can write the prompts. Okay, so the first prompt would be system prompt. So let's just call it system prompt is, so you could say something like, you are a competent and friendly customer service, um, customer service support um, personnel. You are expected to respond to customer queries and complaints. Um, by the way, right, there's one other thing you could do with this. It is actually easy to solve this by generating, right? I could have done this by generation, but I always like people to also think about it. But one thing you could do is take this and um, take this and actually put it in any of our um, you know, chats chatbots like mm, Gemini, ChatGPT or something. And it can actually, in fact, right here you even have Gemini. Yeah. So generate prompts for the following um prompt chain. I don't typically like to do this in class, but then could do that. So while it is doing that, I will continue with mine. So you have a system prompt. Yeah, I'm just doing this because I want to speed things up anyway. You're a competent and friendly customer service support personnel. You're expected to respond to. Okay, so we have this. I'll just accept. It's going to speed things up. So this is where you talk about productivity. It speeds up your productivity. So I am not. I still have to look at. Um, so let's look at what we got from this. So I'm still writing mine, but it's generated all of this. So prompt identify intent. So this is the first prompt, right? To identify customer intent that has been generated. This is a case of meta prompting, by the way. So we just talked about it. Meta prompting is where you use a prompt to ask the LLM generate and optimize other prompts automatically. So in this, I used a meta prompt to generate prompts. But I still need to fine tune the prompts. In text, I can actually ask this Gemini to improve this prompt, right? Improve the prompt. And because I have set text as well, that's why I had to select. So, okay, so it has actually improved my prompt. So again, this is a case of meta prompting, like we said. So you can actually use LLMs to generate prompts for you and improve them. Again, this is a case of, yeah, it improves my productivity. But like I always say, don't outsource your own brain to it. You still need to look at what was generated and fine tune if necessary. So I'm going to do this then. You're a highly competent, friendly, and empathetic customer service support personnel for an e-commerce site. And your primary goal is to provide excellent support by understanding customer needs, resolving issues. So this is nice. Key responsibilities. So you see the depth of additional detail, additional context that we put into this so that they are it will be better able to generate the right responses for you. Okay, so key responsibilities on the understand Then we have now the first prompt in the prompt chain. So you can see that we are taking the system prompt and we are concatenating it with the specific prompt for the first in the chain, which is your next task is to classify the customer's request into one of the categories. Okay. Now, based on customer's message, which category best describes their request? So this is nice because I was looking for um this placeholder. So typically in prompt templates, you have, or in prompts, you have a placeholder where you can fill in. And you see how this also gives examples. So we have its examples here, product inquiry, order inquiry, and all of that. And then we have examples of how to classify. These three gives you another kind of points to when we say one shot or few shots, right? Where you include one or more exemplary. Remember, I talked about that. You include one or more exemplary um, input-output pairs to train the in-context behavior. So effectively, what this is doing is a two-shot or three-shot. You are adding examples. So you're adding the category. So you are grounding the LLM on choosing a category. You don't let it just pick from the air. You have to give it a list that you control. And then this is where we inject the customer message. So that's the prompt classification request. Now, then after that, we will chain the output from that into the next. So remember, the next step is um, the first one is intent, then the second one is classify requests based on pre-existing categories. So we have the intent. Okay, I missed the intent. This is actually the first prompt, which is identifying the intent. Okay. So again, you have the customer message, and then this is examples of how it should go ahead to identify the intent. So again, you see how this is very specific. It helps the um, language model to to properly classify when you give it examples. And this is always a principle, like we said, um, always follow, give it examples. It's very good at following examples. So that's the first one, intent. The second one is classification, right? Then the third one is the immediate response. So figuring out what it should be and the request requires immediate response or not. So again, you need to give it guidelines of would immediate response and what would not. So, and this is the prompt. Your next task is determining the customer's request requires immediate response, or if it can be handled with standard response time. So respond with true for immediate response or false for standard response. So you can see that we now give it a kind of structured output, because you want this structure and take some code, some part of going to respond to this, going to have some logic in your next to do. Okay. So because of that, you have to enforce a structured output. And in this case, we are just asking the LLM, give us just a single response, either true for an immediate response or false for a standard response. Okay. And then you can even see examples here. Okay. And again, we have, so um, three things out. You've been able to take out the classification, then you've been able to take out how to respond. Then the next task is respond to the product inquiry. Okay. Now you can see that here, if it is an immediate response, product inquiry will need to you need to pull data. So you pull data from database and you inject the product info here. But this is kind of already an example of a RAG, retrieval augmented generation, because you have retrieved some information that the language model doesn't have, and you put it into a variable. Okay. It will now use that to respond. You still have the original message. The original message is still very important because it's needed for context. I see sometimes when people do prompt training, they throw the original context. If you need to, you throw it away. But in this case, it is needed. And you still see there are examples as well. Okay. So, and then the final one, well, the collect fit template, they're asking for product inquiry, you can get the product info. If they're asking for complaint, then can um okay, so now you have a prompt to collect data. Again, you see that there are examples, right? And you see how the system prompt here and specify the customer message. So you collect data. Then the final one that you want to give it a response, you can see that the original message is still injected and additional context, um, which can be based on the intent, can be based on product info and so on. In this particular case, you see that it has kind of there's a branch, there's a point where it branches off. So you have a prompt chain of maybe 5 or 6 prompts. So now let's put everything together. Prompt chains are pretty easy to write, right? We're going to write it first of all by just manually um, chaining it, and then we'll chain it with lang chain. By the way, the name lang chain actually came originally from prompt chaining, but of course, it's far more than that these days. Now we are talking agentic and all of that. Okay, so now I have my let me open up my environment variable of my API key, right? And I will start off by simply just running. Okay, so I have my client. I'm now going to do a simple function here to to call the LLM. So let's call it call LLM. And this is the prompt. So I'm not going to make it too complicated. um, we will just pass in, um, for now, let's use our usual. This can also be in as um, a variable. So let's do that as well. So we'll add let's add the LLM model. So we can go to open router. And by the way, I keep going to open router, but you can also get from Grok as well. Olama models. So and there are a lot of models you can get from here. So remember we talked about models and modality last time, that it actually the capacity, the ability actually depends on um, the type of um, different models are trained for different things. So for um, let's search for Nemotron. I'll go with the Nano again. Probably I could get a better model, but we'll go with that. So I'm going to also create a constant for model name os.get and LLM. Okay. So um so we have model name here now. Okay. So yeah, so let me you have a function um call create specify messages role user prompt. We also can add a system prompt. So that's the interesting thing here. You can add the role system prompt. And so this is like standard. Okay, yeah, so hold on. I should pass the system prompt in here. Um yeah, I'll just pass an empty string for now. So that's what we will pass in here. So that allows us to pass the system prompt. So system prompt, you always pass in with the role system. Okay. Um, so we can add other things like temperature and so on, but I'm not going to bother about all of that. Then we return the response choices message content. I'm going to try out this first with just with, with printing response dot choices. Later on, we're going to see all of the other stuff that comes in here, whether let me take this off. Okay, so we run again. .env gives me true. So true in this case means that um, it has loaded the file. The client is also successful. Then I run the function that's also successful. So we now test the function. We can just say print um, call LLM, right? Um, and that's just to test the function. Okay. So the reason why it's printing twice is because I've already printed it inside here and then I still printed it outside. I just wanted to confirm. So our function is functional. Aha. Right. Now let's go ahead to the chain. So to do the chain, of course, we'll initialize all the different um, prompts. So we have the system prompt, we have the prompt to identify intent, we have the prompt to classify request, we have prompt for the immediate response, and we have uh, product inquiry prompt, and then we have complaints collection data prompt, prompt for polite response. So the chain is basically you could do it, let's do it manually one by one. So you could so response one equals call LLM. So the thing, so when we run this, oh, okay, I made changes to my prompt, so I have to rerun the changes. System prompt is okay, but I need to rerun this change and this one and this one and this one and this one and this one. Okay, so now you see it is saying I am ready to identify the main intent, but I need the actual customer message to do so. So that's because I did not inject it. So this is where we now talk about prompt templates. So we can create a new function for injecting templates, for injecting variables. This is where LangChain does very well, but here we're just passing a prompt. We did not inject anything. LangChain, that was the whole purpose of LangChain to solve these problems. So what I'll do is I'll first of all create a new variable called variables. These are all the things that you want to pass in. Okay. So let's assume that um, the customer message is the first thing. LangChain, we'll see how we do this because this is the where LangChain really plays very well. But we will just have a simple function that says add variables. Okay. And then you have variables prompt, and I'm not going to do all of this. I'll rather have what we call args, which will contain the variables. Okay. So what we would do is prompt.format. Then we would um, expand the variables. The variables should be a dictionary. So if you know Python, what this is doing is that these variables are coming in a dictionary, right? What do I mean by a dictionary? Key value pairs. So each variable has a name. So for example, if the prompt that I am trying to inject variables is the identify intent, the identify intent prompt here has a variable called customer message. So that's what I'll create a dictionary made up of customer message and then the actual message. Okay, and that's what I'll pass in as variables. So in this case, I will um then pass the add variables into this prompt. So I'll do something like this, add variables. So the first prompt, I'll add the variables, then I'll specify the variable I want to add. The variable I want to add is customer message. And that will be maybe I I am having trouble making an order. So let's see what this does first so that we can understand this. All right. In fact, um let me just call this prompt. Okay. So yeah, so prompt, prompt one, which is the first prompt. Right. Okay, my function is not yet in existence, so I need to recreate it. So I'm going to rerun this, and then I'm going to run this. So this function now exists, then I can run this. Um, must be a mapping, not a set. Okay, yeah, so this should have been colon, that's all, instead of a comma. All right, so you can see that this has maybe I should use display. Well, I use display. Maybe I should use print. All right. This is worse. I just needed us to see what is here. So the main thing is that you see that the customer message has been replaced with an actual um with an the actual content I passed in. So with this now, I can pass prompt one in and I will get a response. Um, okay, so I want to check what the error is. 400 is a validation error. Input should be a valid dictionary. Uh, I think the system prompt might be the problem. No, I had that before and it was functioning. So let me rerun this just in case something has changed. Okay. Um, Let me remove the system prompt first. This worked just a few. Uh, when I did this as prompts, identify, it worked. So it seems that there is something that unable to determine without the actual customer message. So when I inject the customer message, it falls apart. I wonder why. So prompt.format is what is causing this problem. Let's try the prompt alone. Okay, let's use I am. It's interesting that the model would choke because I I added okay, so it choked because of this. Um yes, so it's not able to return an intent. Um let me do some debugging. I think I need to change the model. The model is struggling. Uh, so just a single I do not understand how a single quote would crush their endpoint. But that's what just happened. Um, okay, let's try again. So we could also try different okay. So yeah, I am unable to determine intent with a specific customer. Um, right. Okay, so let's give it a prompt. Prompt one now. No system prompt yet. And it fails. So this is when I inject the variable, it fails. And I wonder why. Because really the prompt is the same. I am having trouble making an order. It shouldn't fail. Um, for validation errors, input should be a valid dictionary. So that's interesting. Okay, let's try a different call LLM provider. So this time around we will try let's try with Gemini. Okay. So I'm going to um from Google import Gen AI and then client equals Gen AI client. Um yeah, so I will this is where you can talk about things like model routing and so on, but I still will use okay, response equals client um Client dot so this is models dot um oh, let generate text. Let me run this first. Oh, I need to get the API key. Okay, generate text. Okay, generate content. Um, um, Flash. Okay, so we see our system user prompt, then return response dot text. Let me comment this out. Okay, let's test it. Um, okay, this should be contents. Uh, okay, so okay, um this is not OpenAI standard, so we have to go to Gemini standard. I don't have a system prompt in this case, so we'll need to work it out differently. Well, this is one of the advantages of using something like LangChain, which we'll look at shortly. In this case, we're just let's do this in this case. System prompt. We add we just concatenate the system prompt with the user prompt, which is almost the same thing that these models are doing anyway. Um, okay, so let's write it again. And okay, so how are you? Okay, so this comes through. Now let's continue with this, and I want to see if the prompt chain is going to choke as well. I'm surprised. That's the first time I'm trying prompt chain, and an AI is choking because I injected um, variables. That doesn't make sense. Okay, So we still have a prompt. We've still have, injected the variables. I'm having trouble making an order. And now we will call. Okay. All right. Yeah. Um, um, can only concatenate string, not tuple to string. Um, okay. System prompt is system prompt. So I did not pass that in. I guess I should have handled the non-case. Um, oh, I'm sorry. I missed something. Seems the system prompt is surprised. Can't concatenate. Okay, I think I know what the problem is. Um, yeah. Prompt.format. Oh, this is what caused the problem. The format, I left a comma, so it returns a tuple. Jeez. Just a comma returns a tuple. And so prompt one is actually a tuple rather than being. Okay. Found the problem, fixed the problem. Just a comma at the end. I don't know how many of you have heard of that situation where you left a comma at the end and you spent a week debugging it. That's basically what has happened. Okay, so I have found what the problem was, and that's also what was crashing Open Router. I was injecting a tuple. I don't know how it handled the tuple, so it was crashing rather than a string. That's interesting. Okay, so it was able to give me the intent as being order placement issue um, from prompt one. I can now move on to the next one. So the next one is prompt two. So I can just inline everything, right? So I can do a response two, call LLM prompt two, and system prompt again, and response two. Of course, there's no prompt two, so I'll just do the replace. Anyway, let's do it. Let's do it. Prompt two. So to get prompt two, I need to replace um, add variables. So again, you need to check what the variables are for prompt two, the classify request prompt, um, so that you can replace. That is still the customer message. Okay. So yeah, and then we inject that. So we run this and we run this. So it's able to give me the category as order inquiry. The intent is order placement issue. The category is order inquiry. And we can just keep going like that. Prompt three, um, so prompt three is the um, immediate response. And What are the variables that we need for immediate response? Again, it's just a customer message. So you can see that we could actually bring all the variables into a single, um, we can just reuse the variables. That's what I was trying to do before. So I don't need to keep, um, you know, changing this, right? By the way, here, customer message, we use response one, which is not correct. Um, issue is order placement. Now you see the format has changed a little bit also. So remember what we said about um, randomness, right? It has now it changed a little bit. So one thing you need to take note of is that some of these things may cause problems for you when you want to now pass the output. Okay. Um, so this is prompt two, and I now call with prompt two. And again, I don't want to keep retyping. So variables will give us prompt three. We can look at prompt three. And prompt three is now to identify. So category is a technical support. Um, so we can now call LLM with prompt three, and we specify the system prompt again. Now you can see how we are, yeah, it says it's true. So true meant an urgent problem, while false meant a problem that is not urgent. So here you can now do your magic. If response three is true, then you can do, no, prompt three is not product inquiry. Prompt three is true if it is immediate response. So if it is immediate response, then you may forward it. So you could now use logic like this and say, if it is immediate response, okay, forward the problem immediately to help desk or something, or whoever is supposed to, handle it. That's where you can bring a bit of logic, integrate the LLM response with your logic. But if not, then we can continue with the next one, which is response, which is prompt four. But yeah, this is true anyway. So, but I'm not going to do logic based on this. I'll just continue. Prompt four equals, so product inquiry. Now we want to know what type of issue it is. Want to know what type of issue it is. Um, so after we have done uh, the one that is immediate response. Okay, if it is product inquiry. So here's where we do you check the category if it is product inquiry, because it's the intent or the category that you will use to determine what it is. Now, this is not a product inquiry. If it was a product inquiry, then you would call a database, for example. So that is where you would say something like if response to, which was the category, is product inquiry, then you get product information from the database, and then you would add that product information to this. So for example, you could say variables um, dot extend. So this is adding additional variables. Okay. Then you could add product info. Yeah. So you add a product info in here, and then you can then pass that in. But of course, this will only work if actually this was a product inquiry, but it wasn't a product inquiry. It was order placement, issue with order placement. So we can now go to prompt 5. Um, so prompt 5 is the last prompt. So add variables. Um, to collect data, since it's a complaint, you collect data. So we'll now do um, in this case, the expectation is that it will generate a prompt to the user to ask for, data. So response 5 is call LM. And this should be a full prompt. That's why it's taking a bit of time. So you can see the response that comes from here. To help me understand what might be going on, would you please tell me a bit more about the issue? So here the user will now give the issue, the list of issues, and then that's collecting data, and then the polite response. So I'll just end it with that, and then now the interesting thing is we'll see how we can do this with L-cell with LangChain, right? And you see how much easier and faster it is, right? But well, let's keep going. So um, response 6, sorry, prompt 6, call sorry, add variable um, add variables, and so polite response variables. Again, the variables you need for polite response is still just customer message. We also need the context or action. So let's take the context from or action from the we could add the let's add the context or action. Let's add the intent. Um, the response that had the intent was the first response. Okay. Um, so we can still fine tune that, but we don't have a lot of time left. So this now gives us must have mistyped something. Okay, well, we could just do something like this. Variables equals, so, well, surprised. Okay, let's do it the hard way then. I think I must have lost variables being something I could extend. So customer message. we'll just do that. And so we now have the prompt 6. So response 6 is a prompt call LLM with prompt 6. And we specify the system prompt still. So of course we have put in all the context and we get the response. So this is kind of just manually going through this prompt chain thing. Okay, let's try doing this with LangChain. Okay, so LCell LangChain expression language. So the first thing is LangChain has a concept called a runnable. So everything is a runnable. Basically, it means you can run it. Um, the first thing is there are three main primitives that you would use for LangChain. Okay, the first primitive you would use with LangChain is um, the prompt. The second is the model, and then the third is the parser. So those are the three things. Okay, and we'll look at this again in more detail next week, but I just want to jump ahead a bit. So with LangChain, you can compose all of this because they're all the same shape. They're all the same thing, right? They're all runnables. And you have different kinds of runnables. You have parallel, serial, and all of that. You have input parser, output parser. Then you have prompt and you have model. So the idea is turn it into a runnable. So let's look at it. The first thing is you create a prompt by using this prompt template, which we'll talk about in more detail. So use chat prompt template to create a prompt. A prompt is a runnable as well. You use the chat model to create a model. A model is also a runnable. Then you can chain those. The interesting thing is that the variables, LangChain automatically handles the variables. It actually knows how to handle the variables. Then you have an output parser. So the output parser is what will pass the output into a string because the response that normally comes from LangChain is um, a structured object or a structured dictionary, right? But you just want the output, so you use an output parser to extract it. So you now make a chain by simply chaining the prompt to the model to the parser. That gives you an output. And then you can chain the entire thing, so you can do multiple chains. But now let's just do a simple single chain, and then we'll do the full prompt chain, we'll do it later. So take note of this. You make the chain by using, there is this symbol here, which if you check your keyboard above the backslash, is a pipe symbol. So in Python, that's what is used. Of course, in JavaScript, this symbol is not available. So they use, there is a function that is used to chain it. So what this chain is simply doing is the prompt is chained to the model, which is the LLM model. And then the response from the model is chained through this output parser, and then the output parser will pass it. So when you do that, you create a chain. Then you can invoke the chain using chain.invoke. And when you invoke the chain, you pass in all the variables, including all the variables in the prompt chain or in the prompt template. Okay. So let's try this with just a single prompt and see how much easier it is. So the first thing is you start with the first thing in your chain, which is a model, right? We need to get the model, which we can do it. We can just call it LLM or model. right? In this case, we use chat Google Gen AI, right? And the reason for that is, of course, we're using Google Generative AI, so we have to use Google Gen AI. Um, um, so Google Gen AI, we can just create it, but we need to import it first, and hopefully it is installed um, from LangChain. Um, Google Gen AI. I hope I spelled that correctly. I hope I spelled that correctly. So it's either you have underscore something. Let's see. If this doesn't exist, we'll have to install it. Um, so the correct spelling is either this or Google Gen AI as a single. So let's pip install it first. If this works out, you can actually tell because um, you can tell because this, that's not correct. If this works, then you know it works. The hyphen actually becomes an underscore, right? So it means, let me try this. I can't remember all the names all the time. Now this works. So it is langchain dash Google dash Gen AI. Then, so if this works, that means I am going to import langchain underscore. So you turn the dashes to underscore when you are importing, right? So let's start from that first. And this should be what it should be. Um, I think so. Um, so I feel I should use a lowercase here, but let's see. Of course, I could always check if you're having some difficulty, you can always check the documentation. So from the documentation, they say it's Google Generative AI, chat Google Generative AI. Yeah, so this should work. LangChain, Google Gen AI, chat Google Generative AI. And so I just want to prove that the import is okay. Okay, well, um, I'll let you keep going. So we can now create an instance of it by um, you specify the model. So remember, we have to we have to put the API key properly. The API key for this is either Gemini API key or Google API key, which I already have, so that's okay. Then I just use Gemini 2.5 Flash as a model. So this is like the standard. Okay, it's finally done this. So with this, I have created the LLM. The LLM now exists. It is a runnable, right? I can even directly invoke it, and with with this, you just call invoke, right? What is my name? Um, it's going to give you a response, of course, and this response is now in standard LangChain format, right? And the standard LangChain format, you see AIM content here. So I could have also just gotten the content from it. Of course, it's always better to assign the response to something, so I don't need to keep calling it, right? So LLM exists. It is now runnable. That's the first part. So of these three components that you need, the the model which I have just created, then the prompt, right? Model, prompt, and then the output parser. So we've done the model. Now let's do the prompt. So to do the prompt, we just use, we'll get, as this has shown us, we'll get the chat template from LangChain core, right? So from LangChain core, import chat template, okay? Prompt, chat prompt, actually chat prompt template. Sorry, LangChain core dot prompts, right? Let me double check that. So you import chat prompt template. Okay, so this is a prompt template that you can use to load any prompt from. And then you create a prompt by saying prompt equals chat prompt template dot from template. Then you specify the template. So in this case, we had a template. Let's just use the first template. We're not using a system prompt. The very first template that we used, which is the prompt identify intent template. So let's just use that. Remember, this template has a variable, a dynamic component here, which we'll have to replace later on. So we specify the template here. The template here should be a string, not a file name. Later on, we'll see how we can load templates, prompt templates from files and then use it. So if this is a runnable too. So if we check LLM and we check prompt, you see that we have two runnables. This is the LLM and all the stuff in it. You can see this. And then you have the chat prompt template. You can chain these two already. You can chain these two already. So you can create a chain by chaining these two, which is, you always start with the prompt. Prompt, you chain it into the LLM. So you have chained the prompt to the LLM. That means the output from the prompt goes as an input to the LLM. That's how LangChain works. And we could just invoke the chain. So we can do chain.invoke. Now, if I just invoke the chain, it will fail because I needed to pass an input. So let's say the input is, we should actually pass the variables as an input. You can either pass a, if it was a model, by the way, you can also make a chain out of a single thing. So I didn't do this, but let me just do it. I could make a chain out of just the LLM, right? Of course. And LLM dot invoke is chain dot invoke. In that case, is the same thing as LLM dot invoke. But now, I've made a chain by combining a prompt with the LLM. It is interesting that if I try to invoke this chain without any positional argument, it will complain because the prompt has a variable. So I have to pass that variable in, and I pass it in a dictionary. And that, I think it was customer message, which you can see here. And that's the variable, which is the key, and then the value, which is I am having an issue. You can see that I have bypassed two steps here. The first step I have bypassed was having to manage this template. See, I had to write a whole template processing thing here with add variables. I had to write it myself, right? That does the replacement. That will replace the template, but prompt format, passing the all of that. But with LangChain, all of that is, I don't need to do all of that. The internally LangChain is able to do the replacement here. And I invoke the chain, and the response I get is an AI message, which is a full payload, right, in LangChain format. The same thing I got when I invoked LLM alone. So effectively, I'm getting the output from the LLM. I'm getting directly the output from the LLM. That's what you get from the chain. So the output from a chain is always the output from the last element of the chain. The input into a chain is always the input into the first element in the chain or the first piece of the chain in LangChain. This output is an AI message, right? That's the output from the LLM. And that's the same output I get from this chain, right? Because the last piece in the chain is the LLM. So now I need to extract just the response from this. I need to extract just the response. That's where the string parser comes in, which is the third element. If I want to extract just the response, so I can now do parser output. Let's call it output parser. We'll now create a string parser. So of course we have to import it first. And to import, you import string parser from output parsers. So you string output parser. So from LangChain or dot output parsers import string output parser. So we have the string output parser. We now create string output parser, right? And you don't need to do anything else because the string output parser knows how to extract. It knows the LangChain data structure. So it knows that it's trying to extract content. So it's only going to extract the content. So with this now, you append this to the chain. So you create a new chain, right? Which is now made up of the prompt, right? The output from the prompt is chained through this thing into the LLM. The output from the LLM is chained into the output parser. And then you can invoke this chain. And remember, I have to pass in all the variables as well. So you still need to pass in the customer message. Okay. I am not able to make any purchase online. Okay. So when you invoke the chain, you can pass the response. Remember the last output of the output from the chain is the output from the last element, in the chain. And in this case, our parser is going to extract the actual content and show. So I don't even need to do anything. It's going to print it like that. So station now is that the output is giving us intent, technical issue, online purchase. Remember, this matches the instruction we gave in the prompt. So effectively, with this single little thing, we have been able to chain the prompt. You can see how much easier it is now using LangChain. We create an LLM and we can reuse the same LLM for multiple prompts. So we chain this. We did a prompt template, right? And then we did the output parser. So in all of these things, the only thing that really changes is the prompt itself, or specifically the template. So we could actually run this multiple times. Um, I could do another chain, which is prompt. Let's make a new prompt. So prompt 2 is chat prompt template from template. And we pass classify request. That's it. We make a new chain. The only thing that changes is the prompt. We still use the same LLM, we still use the same output parser, and we now invoke with the same, we can use the same customer message. So I could even turn this into a variable and say variables, and right. So I don't need to keep retyping it. So of course I need to execute this here, and then if I execute this, we'll now we'll be running the second one, and it's technical support. So you see how much easier it has become. We can now do prompt 3. Again with that, we create third chain, right? Output parser. Now, of course, the next question you'll be asking me is, how do I chain the previous chains into the next one, right? And we are going to look at that next week, because what we are going to do is we will chain all 6 using LangChain. And in between, we'll be asking ourselves, do we still need output parser in between? Can we chain 3 with chain 4? For information, you can chain chains. So you can have a meta chain, which is a chain of chain 1 and chain 2. But you need to be careful, because how do we how do we pass variables? This is the challenge. Okay, I didn't have a chain 1, but I did have a chain. So the first chain was called chain. So you have a meta chain, which is a chain of chains, and you can still invoke that meta chain and pass in the variables. But I suspect that we'll have challenges with this, right? Because well, you won't, because the variables still work for chain 2 as well. So you can see it basically does that. I could chain up to chain 3. So I now have chains that I am chaining, and you have a full thing, right? And you can chain it all the way to the end. So this is why LangChain is called LangChain, in case you were wondering. And this is what we call chains in LangChain. And after this, then you can do a whole lot of other stuff, right? So when we come on Friday, we're going to see how we can use this in a more powerful way. That's all. Um, are there any questions? Oh yeah, so I have already exhausted my quota. I think we can rerun with um we can use because I basically changed 3 things, but flashlight. Maybe if I use flashlight, it will be but I have to start defining all the chains. So let's see if that works. Run focus cell and all cells below. Yeah, so meta chain got me a false. That's all for today. We'll do more chaining when we come next week. We've already looked at prompt templates. We'll talk more about prompt templates and how to inject variables and other things.